Hello friends, welcome to Max Academy. Today I am here to describe the solution technique of a differential equation. This is very new for you, so please stay with me and see the total video to understand it very clearly. So here the question is, solve 3x plus 2y minus 5 dx plus 2x plus 3y minus 5 into dy is equals to 0. First of all, we have to understand, or we have to justify what type of differential equation is this. To justify this differential equation, we have to just think about what standard structure is this. So if you see this question, then this system is like m dx plus n dy is equals to 0, isn't it? Yes, it is. So what is it? This is a type of differential equation. Now come to the point. What type of differential equation is this? To justify this differential equation, what is m here? We have to let m is 3x plus 2y minus 5 and n is 2x plus 3y minus 5. After selecting m and n, we have to differentiate it partially. Here m is with the operator dx, so m have to differentiate with respect to y. Now going for the solution, I am writing m, let m is equals to 3x 2y minus 5 and n is equals to 2x plus 3y minus 5. Now del y of m is equals to del y 3x plus 2y minus 5, and then it will be 0 plus 2 minus 0 is equals to 0, and del x of n is equals to del x 2x plus 3y minus 5. So this is 2 plus 0 minus 0 is equals to 0. Therefore we can write del m of y is equals to del n of x. Here it is clear to us that since del y of m is equals to 2 and del x of n is equals to also 2, so these two derivatives is equal. What is this? This is the condition of exact differential equation. So this is the given differential equation actually is an exact differential equation. This is justified, and now we have to go for the solution of this exact differential equation. I have discussed this technique in my previous videos. If you want to see, then please go for the description box and I will give it to you. You may see from there. Now I am going to the solution technique for the exact differential equation. Writing now, integrating this one, that is 3x plus 2y plus minus 5 dx, where y is constant. And now plus integration, here the x free term, come on, there is x, so this is not x free term. There is no x, so this is x free term. There is no x, so this is also x free term. So you have to integrate only this term, not this one, because of this is included x. dy is equals to 0. Here x free terms. This is not important to mention. I am writing it for the betterment of you. Now integrate. Just distribute this integrating operator in between these terms. Here 3 is a constant, we can take it out. X dx plus 2y is a constant, y as constant, 2 also constant, so 2y is a constant, then dx, integration of dx only, minus 5 is a constant, then it is dx, plus 3 is a constant, so y dy minus 5 constant dy is equals to 0. Now come on, 3. So this is a formula. What is formula? X to the power n dx. We can write x to the power n plus 1 divided by n plus 1. What is the power of? Here power is only 1. So if you replace this n by using 1, so it will be 1 divided by 1. So x square divided by 2. Therefore, integration of x dx is equals to x square divided by 2. Now we can write down here x square divided by 2 plus 2y, integration of dx is equals to x only, minus 5x here, plus 3y square divided by 2 minus 5y. Since this is infinite integration, we have to put an integrating constant. Here it is c is equals to 0. After that, we can write down 3 by 2, that is 3x square divided by 2 plus 2xy minus 5x plus 3y square divided by 2 minus 5y plus c is equals to 0. This is our desired solution of the given differential equation. If you think this video is helpful to you, please like my video, subscribe my channel and share it to your friends. Thank you very much.